called parent functions and transformations. And we're going to be working with graphs, okay? So what exactly is a parent function? A parent function is a function in the simplest form of family of functions that preserves the definition or shape of the entire family. So a parent function is how your graph starts out. How it starts out with an equation and what it's going to look like based on that equation. Okay? So you guys haven't understood so far, or some of you might have, that your certain equations determine what your graph is going to look like. So we're going to go through 13 different parent functions today. And we're going to talk about what their equations are going to start with and what their graphs are going to look like. Okay, so the first one we're going to start with is linear. And what does linear mean? Linear means we're working with a what? What did we say linear was? We're working with a line, right? So f of x, what is f of x? You guys unmute yourself so you can answer questions. What is f of x? What did we say f of x was? F of x equals y. So y equals x. And anytime your equation starts with x by itself, that means that you're going to be working with a line. So if I just have x by itself, it's going to start at the origin, which is 0, and your parent functions always start at or go through 0. So anytime you have x by itself and you have a number or a expression after, it's going to determine that you're going to be working with a line. So we're going to go back and we're going to kind of review, what is my domain here? What is my domain for that line? Anybody? What would my domain be here?
Purple line.
Yes, but what is my domain?
Negative infinity, positive infinity.
Very good. Negative infinity to positive infinity. And what is my range? My range is my y value. So what is my range going to be?
Negative infinity and positive infinity.
Very good. Negative infinity to positive infinity. Good. So anytime you see your first expression, y equals x, you know you're working with a line. So we have a linear function. The next parent function we're going to be working with is called a constant. What does constant mean? You guys have heard this word. You know this vocabulary word. What is a constant? Constant is a what?
I forgot.
Constant is a number without a variable. So you notice that you have y equals 1. So I'm going to graph y equals 1. I'm going to go here, start at 0, and I'm going to go up 1. And y equals 1. There's my line. So it means you're either working with your x value or your y value. X obviously would be a vertical line, and y is going to be your horizontal line. So what is my domain here? Anybody?
Negative infinity.
Negative infinity to
Positive.
positive. And what is my range?
Same thing.
No, range is y.
Oh.
What does it say y equals?
1.
1. So your range is 1. So you either have x or y. So we're talking, first we have linear, our linear function that looks like a line. Then we have our constant, which is just x equals or y equals. Our third parent function is a square root. And obviously that's not a square root. So we're going to cancel, that's a typo. We're working with a square root function. And our square root function looks like obviously, a square root. So we have the square root of x. So anytime you see your equation start with the square root of x, you know that your graph is going to look like this. It kind of looks like an arrow, a shooting star kind of. So what is my domain here? My domain, is it my x or my y?
X.
X. And where is x starting?
0.
At 0. So you notice your line started at 0. So anything's greater than, because it's going to be anything greater than 0. And what is my range? My range is my y value. So what?
Positive infinity.
Where is it starting at though? Where's the range starting at? Where's my y value starting at?
0.
0. So they're both starting at 0. Your parent functions start at 0 or go through your origin. Either way, they're both, this starts at 0 or goes through 0. This starts at 0. So you're going to notice that your parent functions always either go through 0 or start at the origin first. A quadratic function. You guys have seen these quadratic functions and you didn't even realize you were seeing them. Anything that starts with x squared first, so y equals x squared, your graph is going to look like this. You guys have all seen that, right? It looks like a U-shaped. There's a name for this. This is called a parabola. You're going to have to know that, a parabola. And that's that U-shaped horseshoe-looking type of graph. And anytime your equation starts with x squared, you're going to notice that you're going to have that U-shaped graph. So what is my domain here?
Negative infinity, positive infinity.
Good. And what is my range?
0 and infinity.
My y is anything greater than 0. Good. Okay, so we have linear, we have constant, we have square root, we have quadratic. Our next parent function is cube root, which is obviously just like your square root, but a cube means what? Cube means 3.
2.
So squared is 3, square root is 2, cubed is 3, so y equals the cube root of x. And anytime you see your equation start with the cube root of x, your graph is going to look like this. It's almost like a funny looking S. And so, what is my domain here?
Negative infinity and positive infinity.
Good. And my range is also negative infinity to positive infinity. So we have linear, we have quadratic, we have cube root, we have constant, we have linear, and now we have cubic. And cubic is just cubed. So x cubed. It's without the square root, it's without the root. So y equals x cubed. And anytime your graph starts with x cubed, your equation starts with x cubed, your graph is going to look like this. So now it's the vertical. Your cubic is horizontal. Your cubic is vertical. So what is my domain here? It's the same thing as cubic or cube root, negative infinity to positive infinity, negative infinity to positive infinity for my y value. And so we're going to go to our next parent function. Our next parent function is going to be exponential. How many of you guys have heard the word exponential? How many of you know what that word means?
No.
That word means that it rises really fast. So you notice here's your origin right here. This is where my two axes meet. And our exponent is going to be our x value because it can just depend on what that value is. And our base is going to be an e to the power of x. Okay, and that's how you're going to put it in your graphing calculator. So y equals e to the power of x. And anytime your equation looks like that, or to the power of x, your graph is going to start at 0 and then it's going to go all the way up very quickly. But it starts at 0. Does it cross at 0? No, it crosses at the 1, but it starts at 0. So what is my domain here? My domain would be negative infinity to positive infinity. And what is my range?
0.
Y is greater than 0. Yeah, very good. Okay, so we have exponential. We have two more graphs that you guys are going to learn just really quickly, and then we're going to practice these in your graphing calculator so you know how to work it today. You have the absolute value. You guys know what absolute value is because we've been working on absolute value equations. So anything in absolute value bars. And this is one of your easiest ones because anytime you see the absolute value, it looks like a V. V for value. It's not a very straight line, but it will work. V for value. And it starts at the origin. It starts at 0. And so what is my domain here? It's going to be negative infinity to positive infinity. And your range is going to be anything greater than or equal to 0. And the last function you're going to have, and I'm going to put this on our Google Classroom, this whole video that we're going through, is your reciprocal function. And you notice that your reciprocal, what does the word reciprocal mean? You guys know what reciprocal means. What does reciprocal mean? You do the opposite. It flips, right? So you notice you have two lines and they're going the opposite directions. We have two lines. And we learned about horizontal and vertical asymptotes where it almost touches that line, but it doesn't quite touch it. And you notice that your function is written like a fraction. F of x equals 1 over x. So we're going to put these in our Desmos calculator, and I put this link on your, so let's go through here just really quickly. We're going to start with linear, and linear looks like a line, and it starts or goes through 0. Constant is your x or your y value based on what number it gives you. Square root is the square root of x, and it looks like it starts at 0 and it's shooting to the right. Quadratic is that U-shaped graph, and it starts with x squared, and it has a parabola. Cube root is to the power of 3 with your root, and it goes through 0. So they all start at 0 or go through 0. Cubic also goes through the origin. Exponential starts at 0 but does not cross at 0. Absolute value starts at 0 with the absolute value bars. And reciprocal is your fraction that has the two different lines. So let's go through Desmos. So I put this link on your Google Classroom yesterday. You're going to need to use this. It has almost the exact same calculator that Delta Math does, okay? And you notice right here on the left-hand side, you have different lines. It has number 1, and I can plug in several different lines and keep going, and they're going to be different colors. So the first thing I'm going to do is I'm going to plug in my graph, my parent function for linear. And linear was f of x equals x. So when I plug in x, what do I get? I get a line that's going through 0. Now let's put our next one, let's do quadratic. So let's do x squared. What do you notice? What do we call that U-shaped graph?
Something with the P.
Something with a P, a parabola. Now let's look at what a square root looks like. The square root of x. Now where does that start at?
0.
0. And I forgot to go, let's go back to our x squared. Whoops. Where does our parabola start at?
0.
0. Good. Let's do exponential. So remember, it was the base was e to the power of x. So we're going to put our x. And then where does that start at? It starts at 0. Where does it cross? Whoops. Where does that cross at? It crosses at the
1.
at the 1 on the y-axis. Good. So let's do, what was another one? Absolute value. So we have the absolute value. Where does that start at?
0.
0. So you notice that all of your parent functions start at 0 or go to 0. So let's look at x cubed. X cubed. And you notice your function starts at 0. You can also do the cube root. Okay, so on your worksheet today, I'm going to do a few of these with you. And we're going to start with, let's go back to your worksheet. And it says, write the equation for each parent function and then sketch the graph. So if we had linear, what was our graph going to look like if we have a linear parent function? What is my graph going to look like? Anybody? It's going to look like a line. And it goes through where? Where is it going to start at or go through?
0.
0. And then what is my equation? My equation is f of x equals what? What is my parent function? Equals, what did I plug into Desmos just to get a line by itself? Do you remember? F of x equals x. Anytime you have x by itself, it's just a line. So let's go to the next one. We have exponential. What did exponential look like? It started at 0 and then it rises really quickly and passes out the 1 and it goes up. And my equation is f of x equals, anybody?
Squared.
E to the power of x. Close. It's going to be an exponent. E to the power of x. And then our last one was absolute value. What does absolute value look like? Do you guys remember? This one was our easier one because it has the shape in its name. A V for value, and it starts at 0. So we have f of x equals x, the absolute value of x. Okay, so my next question is, and this is on your worksheet, so if you want to be writing this down, you can. It will help you when you go back to do your work. It says, what happens to any graph when we put a negative in front of the x? So we're going to go back to our Desmos. And what was my linear function? What if I want a parent function for linear, what am I going to put? What is my equation? I have to plug in my equation, so what am I going to put? X. I'm just going to, so you notice that you have that green line, right? And it has a positive slope, so it's starting at the left and it's moving to the right. Starting at the bottom left-hand side, it's moving to the right-hand side. So let's see what happens when we put a negative in front of that x. What happens to that line?
It goes down.
It goes down. Now it's starting at the top at the left-hand side and going to the bottom at the right-hand side. So what did that line do? Well, let's look and see. Let's do another one. Let's try x squared. Let's try our quadratic. And it's that U-shaped. So what is our, it looks like a U, right? Let's put our negative in front of that and see what happens. What happens to that line?
It flips sides.
It flips. So let's look at x squared. Let's do the square root, the parent function of x squared. So we have the square root of x, and you notice that line right there, right? So what happens when we put a negative in front of the square root of x? What happens to that line? It flips. Let's try the absolute value of x. If I have the absolute value of x, what do I have right there? I have that V shape. What happens when I put a negative in front of it? What happens to that?
Same thing.
Same thing. So anytime you put a negative in front of your equation, so the question says, what happens to a graph when we put a negative in front of the x? What happens to it? It flips. Okay, so let's look and see what happens when we add numbers to this. So we're going to start with our parent function, y equals x. So what does that look like? What does our linear parent function look like?
A line.
A line, and where does it go through?
0.
0. So we have 0. Right? And so let's see what happens here. We're going to go, and our next question is graph and sketch. Well, pull it up. X plus 3. So let's go over to Desmos and see what happens when we have x plus 3. So you're going to have to use Desmos today to answer your questions. So I know what x looks like, the absolute value of x, or the parent function of x. But and it's starting at 0, right? So my parent function line is black, and I'm going to go, what happens when I add 3? What happens to that line?
It goes up.
It goes up how many?
3.
3. So it shifts up 3 units. So we're going to put that on our paper, or you're going to write that and put it on your paper in a minute. Shifts up 3 units. Let's do another one. Our next one is x minus 5. So let's see what happens with x minus 5. Let's go back to Desmos, and we're going to plug in, there's our parent function of x, our black line, and we're going to plug in x minus 5 on our second line. And what happens to that blue line?
It goes down 5.
It goes down. So what happens when you add? So we're going to go back here to our worksheet and we're going to say it shifts down 3 units. So without even looking at our next one, before we plug it into our calculator, if we have x plus 2, what is that going to do? What do you think that's going to do? If it's plus 2, what do you think that line is going to look like? Where am I going to put that line through? If it's plus 2, I'm going to start at 0 and I'm going to go up 2. And let's make sure that that's right, because if you add 2, you're shifting up 2, and if you're subtracting, you're shifting down. So let's go to Desmos and make sure we're right. So we have x plus 2, whoops, x plus 2. And where does that line go through? It goes through 2. So what you're going to do today on your worksheet, you're going to use your Desmos calculator to answer the questions. You're going to do exponential parent graphs, absolute value, and then the backside you're going to do absolute value. Obviously, we're working with graphs today, and it's very hard to do graphs. So you can do one of two things. You can put your answers into a Google Doc, but you're going to have to find a way to put your graphs in Google Docs, or you can do it on notebook paper and just sketch a graph and then take a picture and upload it with your work, okay? Either way, you have to turn your work in order to receive credit, okay? Questions. What would your questions be for today?